So next one, we are going to talk about the hydraulic garage lift, how this hydraulic garage lift works. So you might have seen, I have already said, the car can be lifted by a person by using this hydraulic garage lift. So how it works, this hydraulic garage lift? So let's see. So there consists of 3 cylinders of the different diameter. Okay, so let me construct this. So this one is the small cylinder, right? And next one is comparatively large cylinder are present here. Okay, this is the figure for this hydraulic garage lift. Okay, and there consists of 2 valves. So one valve is present here. Okay, one valve is present here. So this is the one-way valve. Okay, this is one-way valve, and next valve is present here. This one is next valve. Okay, and this cylinder, it is called the reservoir, and this one is the large piston, right? And this one is the small piston. So I will put here the piston. It's of a larger cylinder one, right, where the load can be lifted up, and this is the small piston, right, where we apply the force, less amount of force we apply here, and this one is called the reservoir. Okay, and this reservoir and the large cylinder are connected with the small tube. Let's say this one. So it is connected with the stopper. Okay, so this one is called the stopper. Let's say it is the stopper T. Okay, so this one is stopper T. So you can practice this figure yourself also, this one. Okay, and here the liquid is filled one, right? Liquid is filled. So this one is liquid. This is liquid. This one also liquid. Okay, you can see this in the screen also. There I have kept the figure also, right? So this one is the hydraulic garage lift. Okay, so you can put here the some vehicle. So let's say this one is vehicle, right? This one is vehicle. Okay, let's say this one is vehicle. Okay, and here consists of this lever also, it consists. Okay, lever mean we apply the force here with the help of lever. Okay, this is the structure of this hydraulic garage lift, right? So how it works, let's say, so this I will represent this valve A, this one is valve A, and this one is valve B. This is valve B. So this I have said it is the stopper one. So this is construction of this hydraulic garage lift. Okay, so how it works, let's say, so this one is, here is also contained the liquid, and this one is stopper. Okay, so let's see the working of this hydraulic garage lift, right? Okay, this is the larger piston, right, where the load can be lifted up, right? This is the small piston where we apply the force. Okay, and similarly this one is called the reservoir, so collections for the liquid, right? So how it works, let's see. So when we apply the force, okay, when we apply the force on this piston, right, in the lever, especially in the lever, then certain amount of force is exerted on it. So can I write down this P1? So what I have said is, when certain amount of force, okay, certain amount of force is exerted on this piston, then certain amount of pressure is exerted on it. So I have represented this by P1. Okay, then according to the Pascal's law, the same amount of pressure is transmitted in all the direction perpendicularly and equally. That means whatever pressure is applied on it, then the same amount of pressure is transmitted to all the direction perpendicularly and the equally. Mean in this direction also the pressure is exerted one, in this direction also same amount of pressure is exerted one, and in this direction also same amount of pressure is exerted one, right. That means this is one way valve, mean the liquid cannot pass on here. Why? Because this is get closed one, right. This is one way valve. I have said the pressure exerted on this valve get closed the valve, right. And this also there is no any place to transmit the pressure, but here the pressure get transmit through this valve B, and that pressure will exerted on this one, right. On the larger cylinder the pressure is exerted one, and this pressure cause the certain amount of force on this piston, and the vehicle is lifted up, right. That means whenever we apply the force continuously here, then the this vehicle is get continuously lifted up by the applications of this Pascal's law. And after this lifting on the certain height, whenever we need to reset this, whenever we need to get back this vehicle on the same level of ground, then for that this stopper is useful one, right. So whenever we open this stopper, then the liquid from this chamber, this larger cylinder get transmitted to this the reservoir one. And similarly, when this liquid, when we lifted up this piston in the upward direction, in that condition the pressure, this liquid pressure or the pressure get decrease here, some space is created over there, this space is filled with the liquid from this chamber. What I mean is, when we lifted this lever in the upward direction, this valve B get closed, it's a one way, right, it get closed one, then some vacuum is created over there, this vacuum is filled from the liquid from this reservoir to the liquid is transmitted to this the small chamber. So in this way this hydraulic garage lift work, and especially this is used for the maintenance of a vehicles, right, and for the over there you might have seen that cleaning of car, right, this car service center, there this hydraulic garage lift are used one. So this is also the applications of the Pascal's law in our day-to-day life. And next one, hydraulic brake is there. Okay, hydraulic brake is there. So you can draw the figure along with me for this hydraulic brake also. Okay, so let's try to draw the figure of this hydraulic brake. You can continue with me. So this one, right, and it is connected with the cylinder. Okay, the two cylinders are present over there. So this one, this is piston, right, this one also piston, and from here it is connected with the next one piston. So this is next piston. Okay, you can feel the fluid here, right, and here is presence of this pedal. Okay, this pedal is present over there, and this rim is connected with the brake shoe. You might have heard about the brake shoe. It is made with the rough surface, right, and this brake shoe, it is connected with the inner rim of the wheel. Okay, this one is the inner rim of a wheel. So this is inner rim. So let's label this one. So this one is inner rim of wheel. Okay, and this one is called slave cylinder, right. This one is called slave cylinder. So this one is called, it is called the slave cylinder, right, and this one is called the master cylinder. This is called the master cylinder. So this liquid is filled here. Okay, the liquid is filled here. So this one is called the brake shoe, right. So this is brake shoe, this one is called slave cylinder, and this is inner rim of the wheel, and this one is master cylinder, and this portion which we have seen, it is called the pedal, where the brake is applied one, right. Okay, so how it works, let's see. I will explain in short. Okay, so this whenever we apply the force on this pedal, right, we apply the force in this pedal, then the force applied on the pedal cause the pressure exerted on this master cylinder. Okay, and from this master cylinder the pressure will equally distribute to this slave cylinder, and this slave cylinder cause the force on this portion, right, which cause the brake shoe push towards the inner rim, which slow down the velocity and come completely on the rest. Okay, so by applying this we can stop the very heavy vehicle also. So today we have learned about this Pascal's law and some applications of this Pascal's law. So next time we continue the remaining portion. So thank you very much for joining the class. Thank you very much.